Okay, guys, let's settle down, please. We're starting. Dean, thank you. We're starting. It's filming. Okay. This is number 4. Number 4 review on fluids for the test and the quiz. Okay. Now, on the board, I have a water tank, and I have 2 metals. I have aluminum and I have iron. Okay? Let me ask you, just looking at these, let me ask you a few questions. They're both 1 kilogram. Okay? They're both 1 kilogram. Yes? Okay. What has a greater density? Aluminum or water? And how do you tell? What is a greater density, aluminum or water, and how can you tell? Max?
Aluminum, because it sinks.
Because it sinks. The rule is less dense floats on more dense. Easy? Okay. Next, what has a greater density, aluminum or iron? What is a greater density, aluminum or iron? Yes, Gabe?
I would say iron.
Iron is more dense, and why is that?
I would say it's heavier.
Heavier. So intuitively, you're suspecting that iron is
More compact.
more dense, more compact.
Yeah.
Yeah. Well, your intuition is absolutely correct. But let's see if we can put into words what your intuition tells you already. Max?
Well, you drew iron smaller, and it's the same weight, so it has to be more dense.
Same mass.
Same mass.
Same mass. He said same weight. It is the same weight. But what's significant with density is mass. Yes? Okay? So density equals mass over volume. Okay? Density equals mass over volume. Correct? So I have density of aluminum, density of iron. Correct? Yes? M is the same. Correct? M is the same. M is M. Right? What about the volume? Which has a larger volume by inspection? Aluminum or iron? Aluminum has a larger volume. Correct? So let's make this like this then. Let's make it like this. Does that make sense? Is that okay? Now, when the numerator is constant and I blow up the denominator, what happens to the quotient? Okay? This is the quotient. That's the quotient. That quotient is represented by the number density, by whatever number that is, correct? So that's the denominator, that's the numerator, that whole thing is the quotient, represented by that. So that is the quotient, correct? Now, if I keep mass constant and I raise the denominator, I increase the denominator, what happens to the quotient? Does it get large or small? Jack? Smaller. You get that? Yes? Lana's looking at me like, okay, let's see, okay? 1 over 10 versus 1 over 1. I'm going to increase the denominator. Correct? I go from 1 to 10. The numerator stays the same. This quotient equals 0.1, right? That's the quotient, 0.1. The quotient here is 1. So as I increase the denominator, what happens to the quotient? It gets smaller, right? You're okay with that? Okay? So what we can do is we can say this. We can say that one is small, correct? And that one is large. Easy? Yes? relatively speaking. Okay? Now, let me ask you the final, most fundamental question relative to fluid mechanics. Are you ready? You sure? Cody, you want to take a shot at this? Look at the pictures, right? You have enough information to answer this question. Aluminum or iron, which has a greater buoyant force? Aluminum or iron, which has a greater buoyant force? And why? The why. Gabe is, oh my God, the why. That's the tough one, why. Everything's easy, as long as you don't have to say why, right? Yeah, everything's easy. Why? Why would iron have a greater buoyant force, Cody? Why? I'd like to know your reasoning. I'm not saying you're wrong or right. Either way, you're still a wonderful person, but I want to know what your reasoning is. You said iron has a greater buoyant force.
I thought it was because it was denser than aluminum.
Okay.
And then aluminum has
All right.
a larger.
All right. So this has to do with a personal belief.
Personally.
I'll just tell you what I
All right. Okay. So, but let me ask you this, Cody. Let me help you with this, okay? Define for me buoyant force. Define for me buoyant force. Lana's doing that squint again. Lana?
The buoyant force is what pushes up against the...
Yeah, but what does that equal?
Well, the aluminum would have...
No, I didn't ask you that. I want to know, what is the buoyant force? I know that it pushes up. It's the upward force, and that's correct. Absolutely. Weight is the downward force. The buoyant force is the upward force. Excellent. But what is it really? How would you get the buoyant force? Design an experiment to get the buoyant force. What would it be? I'll give you any tools you want. Any tools you want. Anything you want. How would you get the buoyant force?
I really forget.
You forget? That's okay. We still think you're wonderful. Okay? It's Hesper week. They just are a mess today. Yes, Max.
Is it relative to volume?
Just can you give me a minute? Can you give me a minute? Sit down. Okay, give me a minute. Buoyant force is the weight of the volume of fluid displaced, correct? Which has a greater volume of fluid displaced, the aluminum or the iron? The aluminum. Which has a larger buoyant force? The aluminum. See you tomorrow.